Hello everybody, how are you doing? Alright, so welcome to my platform. This is Sichamba Jacob. I've got an exam question here. This is advanced calculus. It's for those people who are in university. So if you're in university, you're doing advanced mathematics, you're doing engineering, this is yours. So the first question here, we need to sketch. How do we sketch the region bounded by these limits? So you have to first identify the limit. So you can see this is dy. What is inside will move with what is inside here. The dx will move with what is outside. So for dy, we shall say y is equal to, so this y equal to the limit which is up here, equal to 1. And then another limit, it's y, still with y, equal to the square root of x. So we are done with what is inside, because the y is also inside. We now go to x. So x is equal to, so this dx, now x equal to the limit which is up here, 1. X is equal to a 0, this 0 right here. So that's it. Let me just talk again on how to identify or to pick the limits. So this is dy, meaning this y will move with these limits which are inside. And then here it's dx, x will move with the limits which are outside, because it's also outside there. And these are the limits. So now, before doing anything or to sketch these limits, we must first find their intersection. Mostly this line where it will meet this graph, okay? I mean this equation. This also where it will meet this where it will meet this. So the graph will look like this, or it will look like, the curve will look like this. We've got x and y axis. So automatically it will start from 0, because we know that x is 0. When x is 0, y will also be equal to 0. So this will move like this. Okay? So this is y is equal to square root over x. This is how you get to graph it. And when you equate where they are meeting, this will be like this. X is equal to a 1. It's passing at 1. And then y is equal to a 1. So they are all meeting here at 1, 1. Okay? And this other one, it's right here at 0, 0. So when to find the region, or to shade the region bounded by all these equations or the lines, we're going to follow this side, and this side. We can't get this region because this equation is not involved. Look at this. We have x is equal to 0. So this is x is equal to 0. So meaning this side, it's bounded. X is equal to 1. It's right over here. And y is equal to 1. It's right here. So this side and this side, it's covered. While y is equal to square root of x, it's this graph right here. So it's covered. So meaning this region is a region we're looking for, which is covered on both sides, here, here, and here. Let me just say all the sides, here, here, and here. We can't pick this region because down here, we don't have an equation which is representing this side. So we can't pick this. Therefore, we shall pick this one. So let's shade it. This is how you sketch the graph. So we now go to the next question where they're saying evaluate. To evaluate this one, we can't go direct the way it looks. We've got integral. Okay, so let me not put the limits first of all. Let me not put the limits. So let me just write it We just copy here so that we get to understand. First here I want to write the way to be. So if you've seen, we are moving like this at first. We go up along the y-axis. We first made this curve here, which is represented by this. And then lastly, we made this curve when passing through that. But we have to change. We are going to start with dx, dy. And in terms of changing, we will move in this direction along the x-axis. That's why we're starting with the dx. So what curve, or what equation are we meeting first? We're meeting x is equal to 0, meaning here it's x is equal to 0. And lastly, we are meeting x is equal to y squared. So if we want to make x subject of the formula, since we've got y is equal to square root of x, to make x subject of the formula, we put power 2 both sides. So y power 2 is equal to x. This is what we have. So we can say y power 2. And then here for the y-axis, we get the lower limit, it's here, it's 0, and the upper limit, it's here, it's a 1. So we can now integrate. Since we've changed the limits, we can integrate. So this whole thing will just be equal to the integral from 0 to 1 of x power 2 over a 2. Then here we've got e y power 5 d. Before we put dx, we substitute the limit, so we can put the limits here, and this will say dy. So to those people, if you've not done the basic calculus, please try to do more researches on the basic calculus so that you can understand what I'm doing here. So here we have the integral from 0 to 1. There's 1 over 2. This, okay, 1 over 2, it will come here. Shove x power 2, e y power e power y power 5. Then the limits 0 to y power 2 dy. So we are respecting x, so whatever is equal to y will be treated as a constant. So we can substitute. When we substitute, we are simply getting a y power 4. So when we get this y power 2, substitute where x is, it will be y power 4 times e y power 5 dy. So this 0, when we substitute it, it will just give us a 0. Okay, so it's better we just leave it to avoid wasting our time. So from here we can say 1 over 2. Okay, we integrate this one. We're going to use substitution at this point, so it will give us something like this. This is what we are going to get right over here. Okay, so this is what we are going to get. So now from this stage, let's clean up. We've got 1 over 2, then this and this will cancel. We shall remain with e power y power 5, then the limits 0 to 1. Okay, so we've got 1 over a 2 e power, when we substitute, it will be power 1 minus e power 0. So the answer will be 1 over 2 e minus a 1. This is our answer. Thank you so much for watching. This has been Sichamba Jacob, and bye-bye.